Welcome to On Chemistry. In this video, we are going to see what is Wittig reaction. We will see basics, problems and shortcut. Stay tuned. For quick reference, I given a library of facts. Basically, the reaction is carbonyl compound with ylide give alkene. Based on the ylide stability, you will have either E or Z. Stability of carbanion dictate the stereochemistry. The all basics are here. That's what we are going to see in this video, very detailed way. At first, we will see what is Wittig reaction. Basically, it's a olefination reaction. End product is alkene. You are creating new CC bond. The name Wittig comes from the scientist name. He is Nobel laureate, very famous for his chemistry and his contributions. The starting material is carbonyl. Ylide is another starting material. End product is alkene and phosphine oxide. The simple facts about the reactions are you are converting CO into CH2. Basically, it's a conversion reaction with one more carbon. It is step-up reaction. Alkene can be E or Z based on ylide stability. Here stereoselectivity can be E or Z. Here stereoselectivity can be E or Z. Definitely not the mixture. We will see why very shortly. The reaction is easy to remember because it is a reverse of phosphanalysis. Phosphanalysis, you are converting alkene into carbonyl, here carbonyl into alkene. So the Wittig reaction is reverse of phosphanalysis reaction. Before getting into the detail, we will see what is ylide. Ylide is basically a phosphine combined with alkyl halide. You end up with positive and negatively charged species. It is called ylide. Both charges stay on the same compound. It is ylide. It is very famous for its nucleophilic nature. Basically, it has phosphorus carbon bond. It is a neutral molecule, but charge is very clear and ionic. The extra stability and selectivity come from 3-phenyl group because phosphorus attached with 3-phenyl group, which gives stereoselectivity. The mechanism is far more complicated. Here I given a simple pathway. Starting material you have carbonyl and phosphorus ylide. Ylide attack carbonyl. Simple nucleophilic addition kind of reaction. What really happen is you have 4-member intermediate oxyphosphophetane or butane. This 4-member intermediate promoted by the affinity of phosphorus towards oxygen. It forms 4-member cyclic intermediate. Double bonds are loosened. You have 4-member intermediate. The 4-member ring is unstable like Bayes strain theory. You end up with phosphine and alkene. Now we have to analyze whether the alkene is E or Z. It is decided by the ylide. Before getting into the detail, you should know ylide and stability. Ylide basically a carbanion. It's a nucleophile. If it is attached with electron donating group, it increases the negative charge, create the instability. So electron donating group decrease the stability of ylide. Unstable ylide form. In the case of electron withdrawing group, the negative charge pulled by the electron withdrawing group charges decreases. So it has extra stability. So electron withdrawing group forms stable ylide. Electron donating group form unstable ylide. Here electron donating group can be methyl. Electron withdrawing group can be NO2, CN and carbonyl. Why we are studying this is ylide stability is crucial for alkene formation. The selectivity comes from ylide stability. The reason for selectivity is complicated, but here I given a trick and shortcut to identify the final product. Don't get into the mechanistic details. It is very complicated. Here basically you are analyzing ylide stability. If ylide attached with electron withdrawing group or resonance, stability of ylide is high. So stable thermodynamic product forms because it has more time survives. Form stable product. If electron donating group attached with ylide, ylide stability is low because anion stability is low. The intermediate is reactive. The stereochemistry is Z because it is a kinetic product, very unstable, quickly form whatever available. The shortcut is abbreviation words. W stands for withdrawing, E that is configuration, D stands for donating, then Z. So withdrawing group E form, donating group Z form. So you should memorize the trick. It help you to solve the problems. Then we will see starting material. Why? Because scope of the reaction is very high. Not only it can react with carbonyl, it reacts with ketone, isocyanate, nitroso and imine. Definitely there are more. But final product is simply CH2 attachment. That's why the reaction got popular. Carbonyl to CH2 conversion with different functional groups. So you should know the scope. You should know the products. The problems are best way to learn. So I given some problems for better understanding. Let us see the first problem. Starting material is benzene attached with methyl group, basically ketone, acetophenone. The ylides is phosphorus ylide with COOMe attachment. You should find what will be the final product. First, let us write ylide with charges. Carbon has negative charge. Phosphorus has positive charge. The negative charge attached with carbonate. It is electron withdrawing group due to hybridization. So ylide is stable ylide. So nucleophilic attack happen. New CC bond happen. Then phosphorus oxygen bond happen. 4-member intermediate. So nucleophilic addition to carbonyl with 4-member intermediate. Here ylide is stable ylide. So the product is trans product, or you can say E-alkene. E-alkene means high priority groups on opposite side. So better you memorize the shortcut to find the product. Then the next example, the starting material is linear compound with ketone and ester at the terminal. You are using phosphine ylide. You should find which functional group reacts because you have two carbonyl group, basically chemo selectivity with stereo selectivity. It is a very important problem. Let us see how we can find the product. Here two carbonyl is there, which will be our reaction center. Basically, the question is about carbonyl reactivity, whether the ketone is reactive or ester is reactive. Ketone has positive charge on carbon, but ester positive charge reduced by O, that is mesomeric oxygen. That is the mesomeric oxygen reduce the positive charge. So only ketone is reactive. So the reactivity of ketone is higher than the ester. So ketone reacts. So first step will be attack on carbonyl. Here attack on ester will be minor. Major will be attack on ketone carbonyl. Attack happen. Then 4-member intermediate forms. You have elimination, end up with final product. Most of the time stereochemistry given as a choices in the question. If question don't have stereochemistry context, leave it. Just find the product. This question is designed to find reactivity of carbonyl, that is reactivity of ketone is higher than the ester. Then the next example. Here you have linear compound with two carbonyl group, one phosphine oxide. You are using the base sodium hydride, very strong base. You should find the product. The reaction is super interesting. Why? Because it's an intra-Wittig reaction. The starting material, both ketone and phosphine in the same compound. That's why it is called intra-Wittig. The reaction is more efficient because there is no collision required. So intra is more probable than inter. But let us go by the basics. Here why the base is given. Base here to establish the ylide because you have just phosphine. To form a ylide you have to pull carbon hydrogen, that is not very much reactive. That's why you are using very strong base. It pull the hydrogen, you form the ylide. To identify the reaction you should redraw for the ring structure because it will form a ring due to carbon-carbon bond formation. So draw it like 6-member. The carbonyl attacked by the nucleophile. You have new CC bond. Another driving force for the reaction is stability of ring is higher than the linear chain. So the new carbon-carbon bond forms. Phosphine and oxide remove itself. You have alkene formation. Another driving force for the reaction is conjugation. So multiple driving force. Probability of intra is better than inter. Drives the final product. So you should be always vigilant which is functional group, what reaction is possible. Then we are seeing the next example, benzaldehyde. Benzene you are using, phosphorus ylide is there. You should find what will be the final product. Here starting material is phosphorus ylide. Let us rewrite with charges. You have positive and negative. The negative charge is nucleophile. So we have electrophile and nucleophile. The attack happened. You have new CZ bond, phosphorus and oxygen nearby. Since the ylide is unstable ylide, expected product is Z alkene. So the final product is Z alkene with phosphine oxide elimination. The carbonyl become alkene there. So the concept you have to learn here is stable ylide form E alkene, unstable ylide form Z alkene. Then the next example, here you have cyclohexanone, alpha position you have bromine, long chain compound, phosphine is there, sulfoxy salt is there. You should find what will be the final product. Here you may wonder where is Wittig reaction. First step you should form ylide. For the ylide formation, you have just substitution of bromine by phosphine. Then you have the possibility of ylide. Phosphorus has positive charge. Alpha hydrogen is weak. It can be abstracted by the salt of carbon. It abstracted. You have ylide there. Phosphorus ylide form. Then the ylide form. Ylide is the nucleophile. It attacks the carbonyl. You form the ring. Here possibility of intramolecular is higher than intermolecular. It forms 6-member ring. Carbonyl attacked by the nucleophile. 5-member ring is formed. You have alkene there. This reaction is important because ylide given indirectly. You are generating ylide with phosphine and base. The concept you have to learn here is in the Wittig reaction, not only master the product, you should master the ylide formation.